Welcome. This will be a short tutorial from Chapter 11 of the Fundamental Science and Engineering book discussing the relationship between current, voltage, and resistance. Current, voltage, and resistance, how are they related? The objectives covered in this video will be define voltage, define electric current, define resistance, and finally, understand the relationship between voltage, current, and resistance. I find that when students have a clear understanding of what voltage, current, and resistance are and how they are related, it helps when they begin making calculations of voltage, current, and resistance, and they can truly understand what is going on when they build electric circuits. First of all, what is current? Current is defined as the rate at which electric charge flows. The unit of current is amperes, which has the symbol A. And it is important to understand that electric charge does not come from batteries. Electric charge actually comes from free electrons that are inside of the wires. Wires are made of metals. Metals have many free electrons that are available to do work. And so the source of the electric charge actually comes from the wires and not the battery. And electricity actually comes from the word electrons, which are particles that have a negative charge. The energy carried by the current is what makes electrical devices work. So as the current is moving, it goes through electrical devices, and that movement carries energy that allows electrical devices to work. So when we think of current, we have to think of charge moving, a flowing charge. Well, what is voltage? As we can see from the picture, the voltage is provided by the battery. Voltage, by definition, is electric potential difference. But that's not a very helpful definition. I like to say that voltage is a push on electric charge. Voltage is what actually causes electricity to flow. Remember, the charge is inside of the wires, but a wire alone will not allow charge to flow. That charge must have a push. That push is provided by the battery or the power source. The unit of voltage is the volt, which has the symbol V. In general, the greater the voltage, remember, voltage is the push on charge. The greater the voltage, the greater the rate of flow of electric charge. Which makes sense. If I push the charge harder, then the charge will flow at a higher rate. Finally, what is resistance? Resistance is, by definition, opposition to the flow of charge. The unit of resistance is the ohm, which has the symbol omega. In a way, we can think of resistance as electrical friction. Remember, friction slows down motion, and so resistance slows down the movement of charge. Resistors can be used to prevent too much current from entering small electrical devices. So we use many electrical devices. We have our phones, and we have large devices like a refrigerator or a washing machine. Well, it's clear that our phone doesn't need as much electricity as the washing machine. So electricians, electrical engineers, can design systems using resistors that will prevent too much charge from entering small devices. That is one use of resistors. In general, the greater the resistance, the smaller the rate of flow of electric charge. Now, how are voltage, current, and resistance related? Well, we can use the water analogy of electricity. Analogy simply means we compare one thing to another. So we can compare electricity to water moving through a system of a water pump and pipes. So how are they alike? Well, in the battery supplies voltage just like the water pump supplies water pressure. Also, the electric current flows inside of the wire just like water flows inside of the pipe. And resistance is anything that restricts the flow of water or restricts the flow of charge. So in the case of the pipe, we can see that the pipe gets narrow in this area, and so it's going to cause the charge to slow down. It's going to give it resistance. Over here in the electric circuit, we have a resistor. A resistor could be anything that slows down charge. For instance, if I have a light bulb, that light bulb will use up some of the charge, and so it will slow down the charge. So that light bulb will have resistance. Let's discuss some facts about electricity. Static electricity, like in this picture, can send over 20,000 volts into your finger. Well, the question is, why doesn't this much voltage kill you? The answer is, one, the current is very small. If we look, there's just a small stream of electricity. So although the push is very hard, the current is very small. One example we can think of is if you were to throw a cotton ball at someone. You could throw it very hard, but they would still barely feel it because a cotton ball is so light. So similarly, with electricity, although the voltage is so high, it's such a small amount of current that it's not enough to harm you. It may scare you, but it won't harm you. Secondly, the human body has such great resistance that it prevents the electricity from flowing. Another fact, the electricity inside of the wall outlet is between 220 and 240 volts. Well, the question then is, why can this small amount of voltage kill you? Compared to 20,000 volts, this is very small. So why is it that this amount of voltage can kill us? The answer is the current is very large. So although the voltage is relatively small, there's such a large amount of current that it can be very harmful, even deadly, to human beings. Secondly, the current is so large that it can actually overcome our body's resistance. So let's check for understanding and make sure we understood everything. First question, what causes electricity to flow by providing a push-on charge? The battery or power supply. Remember, the voltage comes from the battery or power supply, and that is the push on the charge. In the water analogy of electricity, the water flow is like what? Current. And lastly, the more blank, the less electricity will flow. The more voltage, the more current, or the more resistance, the less electricity will flow. Well, remember, resistance holds back charge, and so the more resistance there is, the less electricity will flow.